Welcome to SanfordFlipMath. This is PreCalculus. We are working in the Demana Waits Foley Kennedy book. We are in Chapter 6, talking about polar coordinates, and I've already talked a little bit about what polar coordinates mean and done some converting of ordered pairs. And what this video is going to be about is converting actual equations back and forth. And so just a quick little note. So we're going to just do some examples of that. And we'll start obviously with the first one here. And just a reminder, you should be able to look at this and know that this is a circle centered at 0, 0. And its radius would be the square root of 22, because this is like x minus h squared plus y minus k squared equals r squared. And so just some quick little reminders that x squared plus y squared equals r squared. That is a relationship in converting between x squared, y squared, and r squared. Also, tangent theta equals y over x. Oops. X equals r cosine theta, and y equals r sine theta. These are all the things that we're going to use to convert back and forth between polar, rectangular, rectangular, polar. So what you want to do is kind of browse the list for stuff that you recognize. So for instance, x squared plus y squared, I recognize right there. So really, wouldn't this just be r squared equals 22? And when we say polar form, everything has to be about r and or about theta. In other words, no x, no y. Okay? So really, this is kind of done. I would say that most of the time you won't see it that way. We would take the square root of both sides, and technically this would mean square root of 22 and positive or negative. But if I think about how this is going to look, if I go positive square root of 22, which is 4 point something, I go out, and then I could have any angle, okay, and that's what this really means. The negative radii, the negative distances are kind of already covered by the fact that you can go to any angle. So you don't really need the plus or minus for this. So r equals square root of 22 is in polar, and that's probably one of the easiest ones that we're going to see. Okay. Generally, you're going to see set up in such a way that you want to have it r equals. Kind of like when we're talking about rectangular coordinates, normally it's y equals. Normally it's y equals, but it's not always. Okay? All right, well, let's take the other one that looks kind of like it, and we'll deal with it. This is, again, a circle centered now at -3, 0, and it has a radius of 3. And you should know that from what we did with conics. But now converting this is a little more tricky because we have this +3 jacking things up. So what I'm going to do is some multiplying. I'm going to actually FOIL this out. X squared plus 6x plus 9. Remember, x plus 3 squared means x plus 3 times x plus 3. And I guess I'm going to rearrange this, and I know this feels weird going this way, but remember, x squared plus y squared, I know what that is in polar. So I'm going to write x squared plus y squared plus 6x, and I'm going to subtract 9 from both sides just because it doesn't need to be here. And so this is where I'm at right now. Okay, so as we already said, x squared plus y squared is r squared. Okay, so that much is r squared. Plus, and then 6x, well, x is, as we mentioned before, r cosine theta. So this is going to be 6r cosine theta equals 0. Then the only other thing would be if we could factor this thing or find a way to get r by itself. Okay, so I noticed that there's an r in common here. So I'm going to factor that out, and we'll see where we're going with this. R times r plus 6 cosine theta. Okay, and then this could be that r is 0, or it could be that r plus 6 cosine theta equals 0. And I'm just going to keep going just a little bit more with this, and then we'll talk about what needs to happen. So this one can be r equals -6 cosine theta. Okay, so this is kind of how things are looking right now. Okay, now what I'd like to do is just take a minute and think about -6 cosine theta. Okay, and I know what does this thing look like in terms of a graph and things like that is not real obvious. So -6 cosine theta. Well, this is in parametric mode. I'm going to switch over to polar mode. Okay, and then everything's going to be r equals now. So -6 cosine, and when I push the x button, it's doing theta now. Okay, and I think we did a little bit this on the last one. And there is a theta and a theta step, okay, and that can all work. I don't really, I'll tell you, let me switch so you can see a little better what I'm doing, sorry. -6 cosine theta is going to have some negative values. I know that's shocking. So I'm going to go from like -10 on the x's to, I guess, +10. And we'll start with that, and then we'll see what's going on. And I probably could do a zoom standard with this, but I'm not real sure what it'll do to my theta values. So that's why I'm not doing it. Okay. All right. So let's go back, and we have the equation in. All right. Let's just see what's going on. Oh, that's really weird. And why is it doing that? Well, I'm going to guess that we are probably in radian mode, and we are. All right. So I'm going to switch this to degree mode. And the only reason I'm doing this is I know my graph setup is like that. Ah, look at that. So this looks like a circle, and I know the proportions are a little jacked up, but this looks basically like a circle. I don't know if I can do zoom 4 on this. See how that works. Oh, that's nice. So it's clipping some of it, but it's going to go all the way over to -6, I believe. Okay, on the side. And one of the things I want you to notice is it looks to me like it's going through 0. Okay, like what we would consider the origin. Okay. All right, so let's go back over here. And this thing goes through 0, 0, r and theta, 0 and 0 anyway. So do I really need this? And I don't think I do. Okay, so end of story, moral of the story. This is actually a circle, and it is centered at what we think of in rectangular coordinates as -3, 0 with a radius of 3. Well, it still makes that same exact shape. Okay? Well, I think that's kind of cool. All right, so let's do one more going this way, and then we'll switch it up. Okay, so again, x and y. Here are x and y. So this is going to be 2 r cosine theta minus 5 r sine theta equals 7. And the only thing to do now is get r by itself. Well, I have 2 r's, and they are really not like terms, so what I'm going to do is undistribute. I'm going to factor it out. So take r out. Okay, and now I can get r by itself by dividing both sides by that big ugly thing. No offense, big ugly thing. Okay, and I'm dividing on both sides. And I know I'm kind of making a mess here, sorry. Okay, so r equals 2 cosine theta minus 5. Oh, sorry. Oop, that was supposed to be on the bottom. Equals 7 over 2 cosine theta minus 5 sine theta. Okay? And what's amazing to me is this is what the equation of a line looks like. Well, one of the reasons that polar exists is because some things have some really elegant, simple looking equations, even though we think of them as kind of ugly shapes. And you know, we can do that for some things, but rectangular is really set up for things like lines and you know, that are not going through the origin and things like that. So this is one of those situations where polar is not very nice, and that's okay. That's just part of the joys of going back and forth. Okay. All right. Let's do just a little bit of going the other way. Okay. So let me make some quick notes. Okay, so there they are. And so now we want to get rid of r and theta. We want those to go away. We want x and y. Okay, and I don't know why I started writing y first. Okay, so if we want r equals -4, which would be a circle, and it's just that we would start rotating from there, that's all. That's the only difference. Looks just like r equals 4, only we would start the rotation at what we think of as 180 degrees instead. And we want to make this into rectangular. Well, I don't have anything for r, but I do have something for r squared. So really, now you got two ways to go with this. You could say, you know, replace r with the square root of x squared plus y squared. I'm not going to do that. I'm going to square both sides instead. Okay? So when I square both sides, I have to square the -4. R squared equals 16. And now r squared, x squared plus y squared. And yep, that's it. A circle centered at 0, 0 with radius 4. Okay, that's it. All right. Next up, I think what we will do is the r equals 5 cosine theta. Now, I got two ways to go with this. What I'd like to do, well, one of the things I notice is I have something that says r cosine theta here, and I don't have an r here. So what I'm kind of tempted to do is multiply the right side by r, and if I do that, I have to multiply the left side by r. Well, the cool thing about that is it makes the left side r squared. So let's write it so you can see what I mean. So r squared equals, well, I'm going to write this 5r cosine theta. Okay, so r squared, that's x squared plus y squared. We just saw that multiple times now. And our cosine theta is x, so this is 5x. This is rectangular. This is not the form that we typically see this in, though, and I know you're going to be very unhappy with me. But this, as you notice, I have both x squared and y squared. They both have the same coefficient and the same sign, so this is really a circle, and this is not what we think of as the normal form or standard form for a circle. So I'm going to do a little rearranging. So I'm going to write x squared minus 5x plus y squared equals 0. Now, why am I doing that, and why did I leave that extra space? You know, you just don't want to admit it. Half of -5 is -2.5. Squared is 6.25. So I'm going to add 6.25 here. Can't do that on just the one side. Got to do it on both. So this is now x minus 2.5. I know it's a decimal. It's okay. Trust me. It'll be fine. 6.25. And that is standard form. So this is the equation of a circle centered at 2.50 with a radius of the square root of 6.25, which is 2.5. Okay. And let's just do one more. And now all of our little conversion things over here, none of them say anything about secant or cosecant or any of the reciprocal functions. So I'm going to do a little rewriting here. I'm going to rewrite this as -5 over sine theta. Now, slow down. Don't try and make something out of sine theta here. I mean, you could technically make it y over r, but it's much easier if instead what we're going to do is multiply both sides by the sine of theta. So if I multiply by sine of theta here and sine theta here, this is r sine theta equals -5. And r sine theta equals -5, well, r sine theta is y. So this is y equals -5. So it's amazing to me that this thing right here, when you graph it, really what you get is that graph. I think that's kind of amazing. So, okay, well, I'm going to leave it at that. The focus of this video was really just to do some converting back and forth, and that was it. So thank you for watching. This is SanfordFlipMath, again, Chapter 6, Section 4. We are out of here. Bye-bye.